Good morning. In today's class, we will discuss about Lorentz force. What is Lorentz force? Now, you consider a point charge. Let us say we have a point charge Q. We have a point charge Q, and the Q is moving with a velocity V. We have a moving charge Q. Let us have a moving charge which is moving with a velocity V, and it is actually moving in the presence of both fields. Both fields, I mean to say, both in the presence of magnetic field and the electric field. A charge Q is moving with velocity V in the presence of both magnetic field and electric field. Now the net force acting on the charge will be now the sum of electric field, the force due to electric field, and the force due to magnetic field. F electric plus F magnetic. There will be two forces acting on the charge, one due to the electric field, another due to the magnetic field. So what I can conclude is, in the presence of electric field and the magnetic field, the net force on a moving charge particle is called is the sum of the force due to electric field and the force due to the magnetic field, and this force is called as Lorentz force. In presence of magnetic field and electric field, that means a particle is moving in the presence of both the field. In presence of electric field E and magnetic field B, the net force on a moving charge particle is called the net force on a moving charge particle is called Lorentz force. Lorentz force. This force is given by the force is given by net force F is equal to force due to electric field plus force due to magnetic field. Here you can take electric field E and magnetic field B as vectors. Therefore F can be written as, we know the force due to electric field is Q into V. Q into E. Q into electric field plus the force due to magnetic field is Q as V cross B. Q into V cross B. This also we have seen in the last class. So now if I take Q outside, I'll get that as E plus V cross B. This is the net force acting on a moving charge particle in the presence of electric field and the magnetic field, when both the fields are present. And this force is called as Lorentz force. And here remember, we have studied the property of the force due to a magnetic field, and we have seen that this force, the force due to magnetic field, will not accelerate the charged particle, whereas the electric field force, that means the force due to electric field, accelerates the charged particle at rest, or it can make the charged particle to move, or if the charge is already moving, it will further accelerate it, or if the charged particle is moving in the direction opposite to the electric field, then it retards the charge. Those things we have seen in the previous class, the properties of force due to the magnetic field. So remember one thing, the force due to magnetic field Fm cannot accelerate the charged particle. It can only change the direction, whereas the force due to electric field can accelerate or retard the charge depending upon the direction of the moving charge and also the direction of the electric field in which the charge is moving, and how the direction of electric field, whether it is along or in the opposite direction. Now we'll take up some problem based on this force. Now you may take down this. Two particles A and B. Write down this. Two particles A and B. Two particles A and B of masses m and 2m. Of masses m and 2m have charges q and 2q. Respectively. Both these particles are moving with velocities v1 and v2 respectively. v1 and v2 respectively in the same direction, enter the same magnetic field B. In the same direction, enter the same magnetic field B. Enter the same magnetic field B, acting normally to their direction of motion. Acting normally to their direction of motion. If the two forces Fa and Fb, if the two forces Fa and Fb acting on them are in the ratio acting on them are in the ratio 1/2. Find the ratio of their velocities. Now first let us read and understand the problem. Two particles A and B of masses m and 2m have charges q and 2q respectively. Both these particles are moving with velocities v1 and v2 respectively in the same direction, enter the same magnetic field B, acting normally to their direction of motion. If the two forces Fa and Fb acting on them are in the same in the ratio 1/2, find the ratio of their velocities. Now first we will write what are the given quantities. Given two particles A and B. So mass of particle A is mass of particle A is m, that is given. Mass of particle B is 2m. Also they move with velocities v1 and v2. Velocity of particle A, velocity of particle A is v1. Velocity of particle B equal to v2. Now force acting on particle A is, we know in the presence of a magnetic field, the force on a moving charge is given by F is QVB sin theta. In the presence of a magnetic field B, the force acting on a charged particle Q moving with the velocity v is given by this. Now let us apply this equation for this particular sum. Now Fa, Q. Now because particles A and B of masses A and 2m of charges Q and 2q respectively. Now I can say that mass of particle A is m and the charge of particle A is q. Charge of particle A is q. Similarly, given charge of particle B equal to 2q. Therefore, Fa is charge of particle A, that is q, into the velocity is v1 into the magnetic field is B itself, given B, and the direction, the angle between V and B is 90 degree in this case, because acting normally to the direction of B. So given theta is 90 degree. Theta is 90 degree because they are acting normally to the direction of motion, into sin 90. Similarly, force acting on particle B is Fb equal to charge is now 2q into v2 into B, and again same magnetic field and same angle. Now given Fa by Fe is half. Given Fa divided by Fb is equal to half. Therefore, from these two equations, Fa by Fb can be written as also FA divided by FB is equal to, FA is sin 90 is 1, so it is Q into B1B divided by 2Q into B2B. Now Q will cancel, B also will cancel. FA of B is half, so substitute FA by FA is equal to half. Half is equal to B1 by B2, or B1 by B2 is here V1 by 2 V2. 2 will get cancelled, so V1 by V2 is half itself, 1, because here V1 divided by 2 V2 is there, therefore V1 divided by V2 is 1 by 1. The ratio of velocity is 1. The ratio of velocities of two particles is 1. Because given FA by FB is half, also V1 by 2 V2 we get. The 2 get cancelled, and hence V1 by V2 is 1 itself.